Sawadee krap. Thank you, Keattisak, for inviting me to give a talk on a subject matter of great interest to me, and which is Tripartite Research and Development Consortia and how they can be used as vehicles for economic development. Let me perhaps start by setting the scene a little bit. As we all know, we are at the beginning stages of Industry 4.0, and talking to the IEEE crowd, I don't need to explain what they are and so on. If you look at the enabling technologies in the previous era, Industry 3.0, we're talking about technologies like wireless communications, optical, fiber, data networks, computer processing, memory, and so on. And that carries us through Industry 3.0. And nowadays, we're talking about artificial intelligence, blockchain, IoT, 3D printing, and all these new technologies. They are not new now, but they are more to come, of course. And that will fuel the growth and enable different applications, and even new industry sectors will show up in the next decade or so. And the characteristics of these technologies and their enabling sectors is they are all multidisciplinary, and they're global. Even small companies can be a global company nowadays, and everything is fast changing. One thing that still applies is Moore's law, performance versus price, and so on. And again, I just want to set the scene and remind everybody of that. Now, those have changed, give some challenges to traditional industries. You can look at, in front of our eyes, the transportation industry, not only the logistics, supply chain, and those things, but the automobiles. BMW, as their slogan has always been the ultimate driving machine. But if you get into autonomous vehicles, I don't know whether we care about the driving experience or not. And of course, they're changing from batteries to battery fueled compared to gasoline fueled. And the finance industry, or the traditional financial institutions, are being challenged by fintechs, the small startup financial technology companies, and the same can be said about energy and the retail sector and so on. So all these sectors will be undergoing tremendous change. And if you're incumbent, you are really concerned. Like as I know it, Tesla has surpassed General Motors in market cap for a long time ago, right? And they only account for 5% of the vehicles running on the road today. So these are things that if you're not careful, you'll be obsolete. And of course, if you're the CEO of any of these companies, you want to evolve into the new era, say transportation 4.0 or finance 4.0 and so on. It is a high risk and perhaps high reward. And new technology processes we talk about now is no longer gasoline engines, as an example. The innovative products with commercial potential is also a different type of manufacturing as well. Well, it's things like 3D printing, robotics, all changes that. And you need to quickly reach the global markets, because if you now think about General Motors need to develop charging stations and things like that. Not only that, if you slow, then somebody else will start up in a similar in a similar way in a different geographic region, and you're left behind. And of most concern are the new entrants. And this is compounded by different geopolitical factors, regulations, and different technical standards and things like that. And no single company nowadays can evolved into the next era without building alliances. You see more and more alliances being formed. More recently, LG is the battery company in division of LG is teaming up with Ford, and Tesla is with Panasonic, and so on. So those are very common these days. And of particular concern are the small, medium-sized enterprises, because they lack the global reach, and they are relatively small scale, so the access to new technology, not only in their main industry, but there are other side technologies, intellectual property is lacking for them. High quality personnel, as they grow, they need good staff and employees and researchers and engineers, so that's a problem for them. And they may not have technology infrastructure locally to help them to do all these good things. So among other things, they have a limited ability to build alliances, particularly outside their region. Okay, so the governments, from an economic development point of view, they like to be in the leadership position in the emerging industries, the next gen industries, if you will. That's how you grow jobs and becomes prosperous. So a lot of them are focusing on developing a technological ecosystem with all the suppliers and the researchers and the user sector all in their country, if you will. And therefore, they are focusing a lot on supporting their homegrown small companies, attracting the presence of the multinational companies, and building quality labor. And one thing they have is a lot of countries, they have universities, and part of the current challenge of that is how to bridge the brain power of the academic side to help them in the development of new industries. And at the same time, they don't want to subsidize particular companies and picking winners and losers. So that's also a challenge as well. And that leads us to the topic we're talking today. That's the emergence of multi-party consortium. And some of them are formed with the mind of developing an emerging market. For example, the mapping system, like Google Maps, and now it's Apple Maps, and a lot of the new sectors are focusing on, hey, maybe we can do our own, particularly in the auto industry. I'm going to talk a little bit about that in a minute. And focusing on also maybe not emerging markets, but technology applications. Blockchain has a lot of applications, so maybe a different company will say, well, we don't have enough resources ourselves, let's work together cooperatively and develop blockchain applications of value to my company and to my sector. And of course, multi-party consortium have always been focusing on research and development on subject matters of collective interest. Now, we talk about mapping, right? You can see here technology is formed focusing on mapping and other things, of course. And you can see traditional competitors, they are fierce enemies. Audi, BMW, and Daimler, Mercedes-Benz they don't like each other, I suppose, but they see fit to work together. And other suppliers like Bosch and Continental and Mitsubishi, Nippon Telecom, and Pioneer. So these are different countries with different. I don't need to read the names. You can see them. They form this consortium developing mapping technologies. You may have heard about that already. And this slide talk about blockchain consortia. You see a lot of financial companies are really interested in different applications. They don't want to be left behind by having their lunch eaten up by fintechs, for example. Now, the types of R&D consortium, generally speaking, there are three types. The first type is industry academic, and that generally, it's a bilateral. A particular company work with a particular, probably local universities, and work on a project by project basis, and they look at maybe a little bit long-term horizon. If my company is trying to develop a product to market in the next year, I won't work with a professor. It takes too long, and so I do it in-house. But more likely, I work on a longer-term horizon on particular research work that is of interest to me at the company. The second type is quite common, as I mentioned before, these days. This is the two partners we have, Mercedes and BMW, working together, which is unheard of in say 20 years ago or something. And the focus to work together is on critical technologies. It could be battery power, right? It could be new products and new markets. And the motivation generally is that we have complementary skills, doing risk sharing, because the risk is too high, and to generate a competitive advantage that we can share so that we can be more competitive with external competitors. And UOB, you may have heard about that, is a joint venture between BMW and Mercedes, and their focus is UOB will take over the business, if you will, on behalf of the two parents on mobility services, ride-hailing. So you can see all these are new applications in the auto industry, or new subsectors within the automaker industry. And while the two of them are still competing head-on in the traditional automobile world, in selling vehicles and so on. An old example which I've been working for over the years is Bell and Nortel. They form, Nortel is at one time it was the largest equipment manufacturer in Canada. Indeed, they are the fifth in the world at one time. And Bell is the largest telecom operator in Canada, and they form a joint venture called Bell Northern Research. I worked in all three companies in the past, and why is it interesting? At those days, this is Bell still have the monopoly. You remember the telephone companies had monopoly at those days, and they look at the marketplace and they say we have some problems. We need a touch tone phone instead of rotary dial. I'm just using dumb examples to illustrate the point. So they see there's a market for a new technology application, and they will send it to Bell Northern Research to do research work and see whether that works or not. And it works, then Nortel will manufacture it and sell it to Bell and also to other telephone companies around the world. So it's kind of a reinforcing cycle. The operator, Bell, discovered the problems or come up with the problems, and Bell Northern Research solved that problem from a research angle, from a technology angle, and Nortel used that technology to produce a new product and so on. So this is a very successful combination, if you will, and which leads to Nortel being the number 5 market share or sales holder in globally speaking in those days. You can say that there's a similar relationship in the south of the border from Canada, United States, where you may have heard about Bell Labs and Western Electric and AT&T. So they also have that kind of a relationship among themselves. The third type is tripartite, namely industry, academic, and government collaborations. Now, the focus, because of the government involvement, is also in economic development for the region, where the jurisdiction of the government is. And because of that, it's focusing more on the, should I say, emerging technology. We talk about the enabling technologies for Industry 3.0, if you will, in those days, and maybe in the future with enabling technology in 4.0 or Industry 5.0, who knows. And there are some examples of that. The most prominent example is MCC in Austin, Texas, United States. And it's actually its acronym for Microelectronic and Computer Technology Corporation. And it is formed in the 1970s or so, where the United States is facing strong competition from competitors in Japan. They call it the Japan Inc., you may remember. So the government of the United States actually modified their anti-competition law to allow the homegrown technology companies to form partnerships and consortium in the area of R&D so that they can be more efficient. And then it's under those kind of environment that MCC was formed. And indeed, Austin, Texas, you may know that is now grown to be one of the world's technology hubs. And that partly because they started off with MCC decades ago. Another example in the States is the Microelectronic Consortium of North Carolina. So and then TRLabs, I'm going to talk about it in Canada. So as tripartite research consortium goes, there are three parties: the governments, as a group, academic institutions, and the commercial government, academic industry, if you will, to work together. Now, they have common interests or complementary interests. The governments are focusing on economic growth, academic institutions are in research papers and student education, and so on. So these are the interests, and having a consortium can serve the interest in a collaborative way, if you will. Now, in the collaboration, the governments set policy and regulations and have grants for research and development, and they develop infrastructure. Academic institutions, they are the brainchild and the brain power of, they work on research projects of interest to industry participants in that way. And at the same time, they got to train students, graduate and undergraduate students working on various projects of interest to industry. And the multinational companies and small startups, they all contribute various ways. I'm not going to read the slides for you. You can read it yourself. And then in some cases, the application sectors, user sectors, they come in and say, I have a problem in this and that, and if you can solve my problem, I can actually perfect the technology, the solution, by offering my operations as test beds and improve your product along the way, and even become first customers, because I need that to gain my own competitive advantage over other global competitors. And then the startups, the small companies and the multinational companies will produce those products based on the research results of those projects. So that is, in a way, similar to the example I just mentioned with Bell Canada, Nortel, and Bell Norton Research. In this case, Bell becomes a user industries, right? We talk about that. And the supply industries will take the place of Nortel, where they will produce technological products that solve some of the problems of the user industries. And the universities will take the role of the Bell Norton Research. So of course, that is the bondage is not as strong as in the Bell Canada Nortel case, Government is more like the glue to facilitate that kind of interaction. And in so doing, the government side also fulfill one of the challenges they have. Now, in this chart, it talks about the innovation spectrum. On the left-hand side of the screen, you have basic research and all the way to commercialization. So that's different stages in the technology commercialization process. And generally in the past, universities are focusing on the left-hand side, basic research and maybe some applied research, and they are strongly funded by government in the academic setting. On the right-hand side, it's the industry investment. They focus on in the R&D labs. They look at things of commercial potential and develop new products from it. Quite often, we call it the innovation death valley. The two do not talk to each other. They do their own work. The university side publish their research results and say that's a project I finished. Let me work on a different project and so on. We talk about, in some cases, industry-academic collaboration, but that is not very common. So the R&D consortium, the Tripartite Consortium, will help to bridge that gap or fill the death valley, because the ideas can flow from the industry side to the university side, and they solve the problem and they go back to find new product ideas and applications that the industry can take advantage of. So let me talk a little bit about how the design of a tripartite R&D consortium. You can see if you have the three parties, industry, university, government talking together, and let's say we form a tripartite consortium, there are a lot of things to be resolved. Is this a for-profit, not for-profit, and so on. Again, I'm just giving you this list to illustrate there's a lot of things to negotiate, and some of them are coming because there are three different parties. They come from different directions, although they know that the consortium will help them to meet their respective but different goals. To boil it down, there are, maybe you can divide those issues into these headings. Well, what's the tripartite consortium want to do? The mandate, the nature of the company, the corporate issues, who becomes a member, do we allow other new members to join in the long run, how to operate the consortium, there are a number of issues related to them, and what is the input to the consortium, and what are the outputs, and how we share the outputs as partners in the consortium. And of course, how do we measure the performance of this consortium? Those are important issues and design parameters, because if you make any other choice, it will modify the nature of the consortium. So let me, at this point, share with you an example. A company I worked for about 20 years now. I retired about in 2009, so I can talk about it from reasonably objective point of view. TRLabs. So TRLabs is a tripartite consortium, as you may have guessed. And I showed you this slide before. There are different choices. And the choice for TRLabs is this, marked in red. It's focusing on economic development rather than being the best in communication technology research. So on, they say, okay, it's focusing on, it's not for profit, and they focus on pre-competitive research because that can be shared among different industry members, as opposed to competitive research that you don't want to share with each other. After a long discussion, it was decided that it's industry-led. Indeed, the chairman by rule need to come from industry, and then actually because of industry-led, it changes the ownership and board structure slightly. Industry generally have a larger say, if you will. it's not a fixed life. It's a perpetual. It can go on and on forever, if you will. And we decided at the time, not we, but the founding members, decided it's not horizontal membership, namely horizontal is all manufacturers work together. Vertical is the supply chain members work together. With they decided is intersectoral. Technology company can work with energy companies and healthcare operators and so on for application and so on. It's open to anyone, subject to certain qualifications. There are physical labs, and you can do an administrative lab. For example, you have a secretariat and you have project work being performed in various universities or industry labs. But they decided to have physical locations with labs very located very close to universities to fit the students and professors commuting, for example. It's not project oriented, but it's relationship, partnership oriented, and it's focused on applications. Now, this is the next one is interesting. The member involvement. Sometimes you say, if I join the consortium, I just give them treat them as a outsourced R&D shop. I give them a problem and they solve it and let me know. Now, in TRLabs case, it's actually have resident industry researchers working along with academic and in-house researchers that TRLabs hires, and they collaborate and work on joint research projects. And the other interesting is, I say, buffet and a la carte in the sense that if TRLabs is like a buffet restaurant producing good different types of intellectual property. It may be in patents and know-how and different forms. All members, large and small, even if you're a small company, you pay very little. The large company pays much more. You can have a non-exclusive license to use the intellectual property at the same time and in equal footing. So you can look at it as the small companies are more like children paying in a buffet restaurant. They pay $5, and the adults pay maybe $20, but they still can enjoy the same food on the buffet table, as opposed to a la carte where you pay something and you order a meal, you specifically get a particular meal. And implied in it is the TRLabs will hold the intellectual property and patent ownership of all research results and grant licenses to its members. So that's a one form of consortium as exemplified by TRLabs. And of course, if you change any of these choices, you have a different type of consortium with different effects. So the role of TRLabs is to perform applied research and also as a facilitator connector for technology commercialization. Particularly, that's something that the small and medium-sized companies lack. And how is it being measured? Is by, of course, the quality of the intellectual property, the patents, whether they have commercial potential, whether companies actually use them to produce new products or for internal use and whatever. How many academic papers and publications, how many graduates has worked in the TRLabs projects and therefore trained in an appropriate discipline and readily hireable by the industry member. A lot of them will see fit to hire the graduate who work on a project of interest to them, and they have the chance to observe them working for a couple of years before they hire them, right? So that's it. And also how TRLabs supports small companies and startups. The scope, I mentioned that before, is they have different labs, physical labs, and they are present in Western Canada with international collaborations. So this TRLabs started in 1986, and in the early days, there's only five members. You have the government of Alberta, you have Nortel, you have telecom carriers in the Alberta government telephones and Edmonton telephones, and the University of Alberta. As a reminder, in those days, even 1986 and so on, TRLabs is operating still in the Industry 3.0 area as opposed to 4.0. And the research program divisions, because of that, there is no artificial intelligence and so on. At least the industry folks have not generate research projects along those lines, because the research projects are dependent on industry project proposals. And project proposals are generally fall into those 6 areas. And I don't need to read them out. You can and those, you can see, those are enabling technologies for Industry 3.0. And about 20 years later, just before I left TRLabs in 2009, they have grown from 5 members to 91. And you can see a majority of the members are small companies. And they're manufacturers, like Nortel, if you will, service providers, like telephone companies and so on. Indeed, Samsung is one of the members at one time as well. Application users, I'm talking about maybe the healthcare, the hospitals, and that has interested in developing applications that can enable them to do remote diagnosis and those kind of applications. And there are 5 universities involved, and research institutions and so on. So has grown quite a bit. And in terms of geographic scope, it has also grown, have labs in the yellow provinces in central Canada, and they have an associate lab called NUMIC, a New Media Innovation Center in Vancouver. And there's a joint venture with Singapore called Technobridge. And also, TRLabs has also 3 divisions, if you will. Let me explain what that is. Now, the main TRLabs is working on applied research with the research program, as I just talked about. And NEWT stands for New Emerging Wireless Technology or something to that effect. It is a test bed. It allows a small company to test different wireless apps, if you will, using. If you have a wireless app, you need some wireless network to test your app in, whether it is acceptable and can be launched to the public or not. So this is a test bed that. In those days, you may remember that was, the wireless app, and still is a very important growth sector. It also TRLabs also operate an optical network called TRNet. It's a testbed for high bandwidth applications. Okay, so this is not that's the emergence of high-speed fiber optic networks, and this is 11 million 10 gigabit. In those days, is very common now, but in those days, it's nobody runs that kind of a bandwidth and that long as well. So it's a good test bed for different applications. So you're getting back to the R&D consortium. You can see those are the positions of TRLabs and the various divisions they have. Some of you may be interested in who funds, and while TRLabs collects membership fees, 5-year terms, and so on. So in general, about a little bit over half are coming from the federal and the provincial governments in Western Canada, if you will. And then the 11% is from the universities in the form of mostly in-kind contributions, like professors' time and so on. And industry is about 1/3. And the personnel mixed, it's there, as I mentioned before, there's a lot of students which fulfill the education mandate. They work on project of interest to industry. Academic researchers, these are professors, Industries, I mentioned industry. If you have a project of interest to you, you may send your own research engineer to work on part-time on that project. So these are the 11 of them, and TRLabs of course have their own research leaders and in-house researchers. And it runs a fairly lean shop. There's only 16 people in the administration side. Of course, I was one of them. The key outputs, as you expected, are technologies of interest to industry, services, provide services particularly to small companies and startups, and we generate high quality personnel that can be readily employable and generate knowledge. So these are. Now this chart talk about a little bit, the technology output. The red column is over the 20-year period, if you will, roughly speaking. There's over 1,000 technology produced, and how many are being evaluated by our and licensed, if you will, to our industry members. And they will produce products, and some of them may be an important ingredient or technology, enabling technology for a new product, and so on. And these are some of the performance metrics I mentioned. Internationally, the part of our mandate is to build collaborations and exchange information and research and projects and things like that. In TRLabs side, we have a research collaboration with in Thailand. I've been to Bangkok and other places in Thailand quite many times, and that's how I come to know Keattisak and other people. Singapore, I mentioned before, and South Korea and China. On the new side, there's some collaboration between testbeds in Finland, where Nokia is the home country is, and also the Hong Kong side. So these are generally the benefits to industry, particularly small companies. If you look at small companies, we give them credibility. Sometimes the small company will bring their business partners and or customers to visit our lab, and certainly they can claim that they have a big R&D shop to support them, and that give them additional credibility of business partnerships, equipment, skilled personnel, and so on, and also a speed to commercialization. Because if there's a technology coming up, originally it's generated by an industry member with the problem, if you will, and of course it's faster to go through the commercialization process compared to in the traditional way. If a professor invented something, it may not fit the standard. It takes a long time to get commercialized compared to if it is done at TRLabs. Particularly because of our economic development mandate, we want to focus on supporting small companies, and this list is a number of things that we can give advantage to the small companies. And indeed, we ourselves in TRLabs form a TechCom ecosystem with different components already, and that's what I meant by faster speed to commercialization is part of that as well. So this is the TRLabs model, and indeed we have earned some external accolades. Well, talking to the IEEE audience, we actually at one time won the Baker Prize for the best paper, which is an important pat on our back, if you will, and we earned a number of national and regional awards over the years. Also, because we are supported by government, from time to time, different governments. There's a federal government and a provincial government. Before they renew their membership, if you will, they will generally hire a reputable consulting firm to find out whether they get their money's worth, if you will, by being part of TRLabs. And over the years, these are the evaluations that I've been exposed to it. Let me call it a handle from a TRLabs angle. So we all pass with flying colors. And Ernst & Young, for example, actually one of the evaluators, I give you the quote, is one of the model is exemplary and give leverage to all participants. So TRLabs has closed down shop in a couple of years ago, serving for a lifespan of 30 years. And the slogan is "People and Technology for the Future," right? So you may ask, what's wrong with that? Why would it close down shop and so on? In retrospect, I think because sometimes you can see a lot of companies, they enjoy success and they may not have reacted to environmental changes as Industry 3.0 moved to Industry 4.0. The research program has not changed much. And also the balance between being a consortium, you need to strike a good balance between the different interests of industry. Even industry has different segments: the large, small, and the startups, and the user sectors, and the academic community and government. So you need always to strike a good balance. Sometimes the stakeholders change too, right? The original supporters, when they sign the agreement, has moved on, and the new person shows up and say, "Who is this?" And you need to re-justify yourself all the time. And I think most importantly, the business model has not changed to reflect the Industry 4.0, and that's my observation of why it did not survive the changes. Because the strategic capability need to match with the business model, and the board and management need to make sure that the strategic capability also change along with the business model. So basically, I would say the business model has not changed, and for a number of reasons, and that is led to the demise of TRLabs. So my last slide here. What's the next model? What's the right model? That's something that maybe some of us in the audience may think about, give you something to think about. What would be a good business model for the next generation of tripartite consortium with hopefully can enjoy success for another 30 years and so on? And that's a question mark. So with that, I'd like to say Hakun Krap, and thank you very much for spending time with me today.